guys, welcome back. So today we are going to focus our energy on how to find the least common multiple for polynomials. But before we get to our first fun problem, let's go ahead and knock out this cool problem. So let's talk about LCM. The least common multiple for two or more numbers, pretty much the words is like the definition itself. The least common multiple for two or more numbers is the smallest multiple common to the set of numbers. So let's just say I have said quick, what is the least common multiple between 4 and 6? So I'm like, okay, what's the smallest multiple common to 4 and 6? You can do it mentally or you can show some work and we'll copy someone and looks like the answer is 12. 12 is the smallest multiple common to 4 and 6. Now, fun problem number 1 asks, find the least common multiple of 80 and 100. Now, am I going to ask you this question on the test? Of course not, okay? But we are doing this problem to segue into what we're gonna do. Okay, we have different ways to go about it, okay, but today we're gonna focus our energy on how to find the least common multiple by using prime factors. Why that technique? Is it the best technique? Is it the easiest technique? The answer is no, okay, it's not the worst technique either. It's not the worst technique either, but we're gonna focus on this technique again so we can like transition to what we're gonna do today. To find the least common multiple by using prime factors, to find the least common multiple by using prime factors, your first step is to get yourself some factors. So we're going to write each number as a product of prime factors. I took the liberty to show that work. So you do it however you can, and then by some miracle you have that 80 is the same as 2 to the 4th times 5, and 100 is the same as 2 squared times 5 squared. So step 1 complete. How do we find the LCM by using prime factors? Step 1, write each number as a product of prime factors, and then step 2, what's the answer? To find the LCM, you're going to multiply the different factors using the biggest exponent on each prime factor. So the first prime factor that I see is 2. It's recycled elsewhere, so we're going to have to use the biggest exponent. So in this case, it's 4. I know it's not lined up because this is too small for me. A different prime factor that I see is a 5. It's recycled elsewhere, so I have to use the biggest exponent, which is 2. Okay, the square root of 2 is 16. The square root of 2 to the 4th, I said it backwards. 2 to the 4th power is 16. The square root of 5 is 25. And last time I checked, the product of 16 and 25 is 400. So no matter how you found the answer, the least common multiple between 80 and 100 is 400. Fantastic. Now, how do we find the least common multiple for a set of polynomials, which is today's agenda? To find the least common multiple for a set of polynomials, it's also a two-step process. 1, factor each polynomial completely, kind of like write each number as a product of prime numbers, okay, or prime factors. So step 1, factor each polynomial completely. Then step 2, I need you to multiply the different factors using the biggest exponent on each factor. Okay, so from fun problem number 2, we're going to do 3 problems and then we're out. So the directions read, find the LCM of the following polynomials. So I'm like, okay, LCM for polys. Oh, sorry, we're not cool like that. LCM for polynomials. How am I going to handle it? Step 1, factor completely. We have a one-term polynomial, so it's alright, there's nothing to factor. One-term polynomial, so there's nothing to factor. So we're going to jump straight to step 2. So now we're going to multiply the different factors using the biggest exponent on each factor. The first factor that I see is an x. It's recycled elsewhere, so we got to use the biggest exponent, which is 2. Okay, let's put that in our multiplication list. Okay, multiply all the different factors. A different factor that I see anywhere is a y. It's recycled elsewhere, so we got to use the biggest exponent, 8. Now, when we jump into this unit coming from factoring, it's very easy to think about, oh, what do they have in common? GCF. But we're not talking about GCF. We're talking about LCM. Okay, so I'm not really concerned with what is it that they have in common. That's a different question. I want to know what's the smallest multiple that they have in common. So if you have prime factors or variable factors, you got to use the biggest exponent. Cool. So continuing the process, let's go ahead and multiply the different factors. A different factor that I see is a z is not happening elsewhere, so that is its biggest exponent. It'll be z cubed. Cool. So I'm gonna do like a bonus problem. So suppose it just said let me just put BP. Okay, so if we had like 1 over x squared y plus 2 over x y to the 8th z cubed, this is gonna be the only one that's gonna have a bonus problem. And we're asked to add. Okay, so it's like, oh man, like unfortunately the fractions don't have the same denominator. So what are we supposed to do? If the fractions, oh sorry, let's show off our math. If the rational expressions don't have the same denominator, then your first goal is to find that LCD. Okay, so to find the LCD is same difference as LCM. LCD is just the smallest common multiple for a set of denominators, so the words are interchangeable. So again, we can't add these right now because the denominators are not the same. So then we got to think about, oh man, what's the LCD? We just knocked it out. Okay, so that will give us x squared times y to the 8th times z cubed. Oh, we're overachievers. Can we finish it? No. Okay, we're just gonna have to table it, but don't worry, in the next vid we'll add and subtract some really cool rational expressions. But I wanted to point that out. Okay, the reason why we're focusing our energy on how to find the least common multiple is because if we're not cool like how to find the LCM or LCD for a set of polynomials, then this unit where we add or subtract is not going to happen for us. So please pay attention. Okay, so I said we're doing 3 problems. That's our first problem. Let's go ahead and knock out 2 more. Problem B, the polynomials are 6x minus 12 and, where am I, 8x cubed minus 32x. Okay, so then I'm like, okay, what is the least common multiple for these polynomials? So I'm like, I don't know, I gotta get myself some factors. So step 1, factor completely. Looking at the first polynomial, the greatest common factor is 6, and when we factor it out, that will leave us with x minus 2. For the second and that's it, we can't break it down because the degree is 1, so we're cool. For the second polynomial, I believe the greatest common factor is 8x, and if it isn't, we will realize that like right now. When we factored from the expression, that will leave you with x squared minus 4. So we have factored, but remember, we gotta factor completely, okay, or all the way. The degree is more than 1, so we gotta see, can we break it down? And in this case we can. X squared is a perfect square because it's the square of, where am I? It's the square of x. 4 is a perfect square because it's the square of 2. So pretty much we have difference of squares. So x squared minus 4 should factor to x plus 2 times x minus 2. X plus 2 times x minus 2. And again, if you are having a technical difficulty with the factoring, please review the other videos. I'm just going to assume from this point forward that you in factoring get along to minimize the length. Okay, but please go back to the earlier videos on factoring. Okay, so now to answer the question, I'm running out of space. I'm gonna do the LCM on the side. What is the least common multiple? Okay, so first things first, we need to factor completely. Okay, then we need to multiply the different factors using the biggest exponent on each factor. I'm gonna give a little special love to the coefficients. Okay, I mean to the integer factor. Sorry, we got a 6 and we have an 8. Okay, I don't want you to toss in a 6 or 8 because check it out, 6 and 8 are not prime numbers. Okay, so we're just gonna have to think about like our skills. So I'm like, oh, what's the least common multiple between 6 and 8? Handle it however you want. I think it's 24. How did I get that? Oh, because I cheated. Okay, but I didn't really cheat. That's just how I speak. I need to stop speaking like that. Now, if the numbers come to you, fine. And if they don't, you can use prime factors to find the least common multiple between 6 and 8. But I'm going to show you something really cool. We're going to go ahead and use the ladder to find the least common multiple between 6 and 8. We have used the ladder to find the GCF for 2 or more numbers. Now we're going to use the ladder to find the least common multiple. The ladder, you can use it to find the least common multiple for 2 or more numbers as well, but it doesn't work out so nicely after you have 2 numbers. So we're just going to use the ladder if needed if you have 2 numbers. So we're going to go ahead, divide by the first thing that comes to mind. which is 2. 2 goes into 6 3 times and into 8 4 times. Excuse me. Okay, sorry about that. Okay, so we're going to continue to divide until our leftovers don't have any factors in common other than 1. So now the question is, where is the LCD or LCM, depending on if what you're doing? The LCM or LCD is given by the product of all the numbers to the left of the ladder. If it was GCF, we just multiply the ones on the left. But like new LCD or LCM, we multiply everything that's outside the ladder, namely 2 times 3 times 4, and that will give us, where am I, 24. Okay, so you don't have to panic if the numbers don't come to you. I did this problem in the morning, so that's why the numbers are fresh. Okay, so let's do this. So we took care of the integer factors, okay? Least common multiple between 6 and 8 is 24. Now we're gonna take care of the variable factors, kind of like we did in the other problem, and then we're gonna take care of the binomial factors. For the variable factors, we're going to multiply the different variable factors using the biggest exponent on each variable factor. The first and only variable that I see is an x. It's not happening elsewhere, so that is its biggest exponent. Let's go ahead and put that in our multiplication list. So we took care of the integer factors, we took care of the variable factors. Why did I put a dot? I don't know, that's how I check myself, okay? Now we got to focus on the binomial factors. So the binomial factors, you're going to treat them like the prime numbers. Multiply the different binomials using the biggest exponent on each binomial. The first binomial that I see is the x plus 2 is not happening elsewhere, so that is its biggest exponent, which is 1. Let's go ahead and put that in our multiplication list. Another binomial that I see anywhere is the x minus 2 is happening elsewhere, but either way the biggest exponent is 1. Let's put that in our multiplication list. Okay, so thanks to our hard work, the least common multiple between these two polynomials is 24 times x plus 2 times x minus 2. Okay, let's go ahead and do our third and final problem, and then we're out. Okay, problem C. Where am I? So problem C, we have x squared minus 9 and x squared plus 6x plus 9. Fantastic. So prerequisite step is to watch out for common factors. The first polynomial doesn't have any factors in common other than 1. Binomial minus, let's see if we have difference of squares. Someone asked, do I really have to do the mold? You know what? You do not, okay? And I'm writing as I speak, okay? You do not. I choose to do the mold because it helps me. I may not need it for me to actually factor, but I know that when I look at my notes to work on an assessment or something, I'm going to be very thankful that I spoke to myself. You know, think about your notes like your diary where you put all those secrets, okay? In this case, the secrets are our math notes, okay? So this should factor to x plus 3 times its conjugate, x plus 3 times x minus 3, okay? So that's it. The degrees are 1, so we can't break it down. For the next polynomial, there's no GCF to yank out. GCF, I said that right. The leading coefficient is 1, so we don't have to use the AC method to factor unless you really want to. Let's go ahead, throw down parentheses, focus on getting that first term. The product of the first term should give us x squared, so we're going to use variable times itself. To complete the binomial factors, we want factors of c that add up to b, factors of 9 that add up to 6. In this case, it's going to be 3 and 3. Notice how I didn't do an x game, but if you want the x game, because you and the x game are BFFs, go for it. But if you don't need it, then I don't need it, okay? Now, do you have to use exponents for repeated factors? You know what? You don't. But for the purpose of this unit, I recommend that you do. I'm going to put a drop down arrow because for the previous problem, since the polynomials in factored form were not lined up, this was really hard for me to knock out. So I want them lined up. So for the question of the hour, what is the least common multiple between these polynomials? So we don't have integer factors, we don't have variable factors, all we have are binomial factors. So how are we going to handle it? So we're going to multiply all the different factors using the biggest exponent on each factor. The first factor that I see is that x plus 3 is recycled elsewhere, and the biggest exponent is 2. So let's go ahead and toss in 2 factors of x plus 3. A different factor that I see is that x minus 3 is not happening elsewhere, so that's the biggest exponent, which is 1. Okay guys, so unfortunately we've come to the end of this video, so I hope to see you in the next one. Thanks.